Here what I'm going to do is I'm going to be starting with the introduction of Spark documentations. Now, this module that we are discussing, module 3, is an introduction to SQL Data Frame API that is present inside the Apache Spark. Data frame is typically a panel data, right? As you call it in the pandas, panel data. So it is in a form of a tabular structure, rows and columns, and the data set is distributed on multiple nodes which are processing it. So it is a distributed table. We can think of it like that at this moment. And that data frame essentially can be processed in RAM, right? So we're going to be processing it in RAM, and we all know that since the CPU and the RAM both are semiconductors devices, they are fast. They have parity in processing, right? They have parity in processing. They are fast. Whereas other forms of storages like your local SSD, peripheral SSDs, network attached storage, and all those things have some latency involved, right? So Apache Spark Spark essentially is a distributed parallel processing paradigm, a framework of processing the data inside the random access memory rather than on disk or on any other peripheral device. Because we know fastest are the CPU registers, followed by CPU registers, the random access memory, followed by that you have the local SSD, that after that you have peripheral SSD. So like that, so we prefer using RAM, and it's a parallel distributed processing paradigm that you have to process the data inside the random access memory. It has various APIs. It can process for you streams using structured streaming API. It can help you design machine learning models using MLlib API. It can help you process structured data, tabular data, which you typically would do in a business intelligence solution. That will be the SQL data frame API. And Spark has its own language, Spark SQL, instead of standard SQL, which happens to be your American National Standard Institute SQL, 𝐂𝐻𝐫𝐁. So they have their own SQL called a Spark SQL. Essentially, the primitives of the SQL data frame API class itself we will look at very shortly. It also has GraphX, which is for your graphical processing, whereby you look into the entities and their relationships, like social media analytics, network analytics, and so on and so forth. So essentially, it's a diverse product because the original creator of Spark, 𝐂𝐻𝐫𝐻𝐫, his research project it was essentially. So he was fed up with Hadoop ecosystem, because you know that in the Hadoop ecosystem there are so many projects you need to learn, right? You have Impala, a Hive, a Storm, Flume, Hadoop, right? So to do each and every other aspect, to process structured data, go to Hive. To do machine learning, go to Impala. To do some kind of real time, go to Storm and Flume, right? So it was essentially a lot of different products to learn rather than a single unified product. And it was also not processing it in RAM, rather it was on disk, and he was doing machine learning essentially. And machine learning happens to be an iterative, highly resource demanding operation. You are operating on terabytes of data, and not only you're operating on terabytes of data, you're looping over that data. You are carrying out iterations in your hyperdrive experiments. So essentially, that disk-based processing, the map reduce carried out on disk, is essentially not going to work, right? Performance will be suboptimal. Hence, the better operations, better way of essentially processing such heavy volumes of data with such kind of workloads which are iterative in nature is better to be done inside the random access memory. Hence, the clusters are RAM heavy, memory optimized machines. We don't need to go into super duper details of the internals of the cluster at this moment, right? Later down the road in module 5, we will talk about some rudimentary principles of the structure and the architecture of the Spark cluster. At this moment, we quickly look into the programming paradigm, that how do you create data frames sitting on your lake? Then how do you carry out operations on those data frames? And then how do you write them to a lake as well as to the warehouse, typically carrying out modern data warehousing? Okay, so if I take you to the API documentation, we will be leveraging Python It is PySpark, right? Because that is popular among new people, right? If you, let's say, are doing some big data programming, you would be familiar with Java and your Scala, right? But Python is what this course helps you leverage. The reason being that in case people are learning new, they would be easier to reason about that language. So it is Python, and you can see a little bit of theory is written, right? I have literally talked on that. Then there is a link API reference. And if we go inside API reference, we come to the references of the classes and their primitive operations. We first of all go into core classes, right? So if I click on Spark SQL Data Frame API, I have this core classes. So you should quickly take such links. These core classes are super important for us. Primarily at this moment, two classes are important for us. The first class happens to be a Spark session class, and the session object essentially is used to do and carry out every programming construct on a data frame as well as on the Spark cluster, right? So the Spark session will be auto authored, right, for us, which means they auto created for us. We don't need to write it in this form, the builder pattern. If you were to write it using your SBT, then you would have to essentially write this all. But at this moment, because we would be leveraging the platform as a services, Azure Databricks and Synapse, we don't need to author this object. We establish the session, this object is auto created. So this object, why is it important for us? Because it is what helps you do programming using the data set in your Scala and data frame API in your Python, PySpark. So Spark session can be used to create data frames, register them as managed tables, execute SQL, that is your standard SQL using views, right? You could create views and then do that, cache them, read the Parquet file sitting on the lake. To create a Spark session, you could use the builder pattern. As far as our course is concerned, we don't need to use the builder pattern to author a Spark object, session object, because we already have it in our notebooks in Databricks as well as in the notebooks in our Synapse, right? So that's the situation. So essentially people are doing some fireworks, which means some crackers. So all of a sudden temperature in my room has increased. So I have to basically lower down this conditioners. So yeah, so let's get started. So if you look over here, we have some methods in this class which help us author data frames. For instance, create data frame. So if you look at this method essentially helps us author a data frame, create a data frame on a list, a resilient distributed data set RDD, which we will talk subsequently upon, or a pandas data frame. So if you have some explicit data in a form of a list, an RDD, or a pandas data frame, you would be able to essentially create another data frame using this method. Similarly, if you see this method, SQL method, this method also essentially helps us to create a data frame. You write a query on a table, output of that query will be converted to a data frame. So returns a data frame resulting from the result set of a given query. We're going to use all of these, right? So when we're going to use, you will see their concrete implementations, how we are using them. I'm trying to essentially help you reason that what we're trying to do here. Similarly here, if you see this table method, spark.table, right? So this method also essentially helps us author data frames. It returns a specified table as a data frame. You will leverage these also. So you have table, you have SQL, you have create data frame method. All these methods essentially help you author data frames. But where are files? How do you author data frames on files? That's what is more important, because essentially we will have data that would be sitting on the lake in a files, Parquet, Avro, JSON, CSV, TSV, and we need to author data frames on them, create data frames on those files, that is initially read them right from there. That is far more important for us rather than these methods. So then if you look, it has some attributes which return some object that help you do so. So right up front, we see spark.read over here. Spark.read returns a frame reader that can be used to read the data in as a data frame. And using this, essentially, you can read your files. Using the data frame reader, you'll be able to read various files. For instance, here are some methods. So let me share these two again. So let me first read and read stream. Let me share you this in the chat. Read and read stream. These are also important for us. And if you look over here, we have this read, right? Read. And we're going to be leveraging this read over here. You see this read. So read method is there, which helps you read from file types. I have notebooks, so many notebooks of different file types. I would be sharing that. And if you look at this data frame reader object, you see that we have class PySpark.SQL.DataFrameReader, which is going to be leveraging the Spark session object, right? Spark.read. It is an interface to load a data frame from external storage systems. Example file systems, HDFS, Amazon S3, Azure Data Lake Generation 2, key value stores, right? Azure tables and all those things. Spark session.read to access spark.read. So it helps you read CSV. It helps you read JSON load, which is another generic method. Options, various options, ORC, optimize row columnar, Spark, which will be most popular for you. Get the schema out, table, text. So all these methods are super important for us. And for your practice, Microsoft has created a collated list of notebooks using which you would be able to see read and write operations on different types of file types. For instance, ORC, RC, Avro, JSON, XML, Parquet. So here, let me share you that catalog. That catalog needs you to practice, right? Because there are so many file types, we will not be able to look at all of them. The course will look into Parquet, will look into CSV, will look into JSON, right? Other file types you will have to practice through that catalog. So if you look, read Parquet files, I think it was there, no. Azure Databricks, you'll see over here that here is a full list of sources. Binary file, Cassandra, Couch database, Elasticsearch, Logstash, Kibana, image, Hive tables, MLflow, Mongo, Neo4j, Avro, CSV, JSON, LZO compressed, ORC, Parquet, Redis, Snowflake, text files, zip files. Literally all the popular sources and targets are there. Then there is a connectors, JDBC PySpark connectors. Microsoft has also designed their own connector. Microsoft has also designed their own connector, which is called as Synapse SQL connector, which we will discuss subsequently in the subsequent modules. Because essentially after processing your data frame, you would be writing it to some kind of a SQL structured systems for your reporting, multi-dimensional modeling. So that is essentially our connectors also. So if you look, for instance, Parquet, here you can read about the Parquet, the columnar file format, self-describing, that provides optimization of speed of queries, a columnar format, efficient format than CSV JSON. Options, here you see that they are giving you a lot of options, Python, Scala. You can see details of reading it. For instance, you click on this Python to how to read using Python language, it essentially brings you to its same thing that I had here, right? Reader, and then you click on Parquet. So it basically brings you here. Then you would be able to see in detail this data source option. So when we open this data source option, let me first of all share you this broad link. That is all file types read and write data frames. Read and write data frames, right? So here you see that. In this you would see. And then when we click on any of these, then you see the read and write, and then they give a notebook also, to which we are coming very shortly. But if you click on any of these, it essentially takes you over here. Then you click on data source option. So when you click on that, then you get a full list of detail, right? Which at this moment we don't need, right? Essentially, we are not scrutinizing into that level. But if you look, whatever, uh, at the end of the day, if we have some detail to check that how do we do this thing, what option is there for that while reading, writing, whatever, that we're going to find over here in this documentation. So for all of them, they have given you the details that how do you carry out read write. The system, that is this, essentially this course, helps you reason about Parquet files, JSON, CSV, okay, text files, okay, other file types. From here, you're going to have to practice more, okay. And in case you need assistance, I and my colleagues at Microsoft are available, right? We would be happy to assist you, right? The worldwide learning team people. So now the question is that how to leverage this notebook. You just simply right click on this notebook, copy the address of the link, and then subsequently you need to go to your Databricks deployment that you have. And in your Bricks deployment, you'd be able to bring it inside your import, right? So let me show you right from the beginning. When you click on the workspace of your Databricks, you'd be able to go to the users, where you shall see your name, and then you could say, I want to import something which you have given me the URL of, and import. And that would bring essentially the imported notebook, something like this, and which we could connect to our cluster. And subsequently, after connecting it to our cluster, we could carry out all the detailed operations on it, right? So you could go ahead and you could start doing it. So right now you should not look at what all these methods are. Spark context dot parallelized, in order to basically essentially create this multi-dimensional array maps. This would help you create a data frame essentially, using that. But we are interested from here: Scala code, R code, Python code, SQL, right? SQL. So this essentially is a basic method. For instance, if we look at Python here, so spark.read.parquet, from this URL, from this path on your DBFS, Databricks file system, and that would create a data frame for us. And then this spark.read essentially happens to be spark session.read, which will give us a data frame reader. And then the data frame reader has the Parquet, as we can see over here. Data frame reader has this Parquet that will help you read. You can check out all the options that it allows you to play around with, right? So all the options that you could author, which obviously you're going to check in the source over there, essentially over here, right? So all the options that it would allow you to use, that you can leverage, for instance, compressions and encodings and so on and so forth. Okay. Yes. So these files are for practice. Notebooks are given. Similarly, if you look at JSON, here also you see notebooks are there. For first of all, JSON has a lot of variations: single line JSON, multi-line document JSON, JSON lines, and then you have array of documents. A lot of things. JSON has some detail in it, so you're gonna have to read. But at the end of it, as you see, then another notebook to practice it. So we can copy it and essentially bring it back here, and then check out that what are the ways of practicing some reading, writing of JSON, and so on and so forth. So you click here, that's going to create a JSON file in the Databricks utilities file system.put. That's going to create a file for you, and then you go ahead and look at different languages: a Scala language, R language, Python language, how to read the JSON files essentially. Okay. So yes, little bit of hands-on practice would be requested from our people. At the end of the day, you need any assistance, any question, any kind of a support, we are always available. You are just a single query away from the WhatsApp chat. But yes, since the course will discuss few of them, other types you should practice a little bit, and in case you need any assistance, we are always there for you. So what we understood by this interface of SQL method of the data frame API is that the .read method of the Spark session essentially read the files from the lake, and that's what we are interested in at the end of the day. Other file types are here. I've shared you the links, and then you have a detailed list of SQL guide in which you see source options and all that thing. Other methods, if you see, of the Spark session class are Spark session class. Here we see that read stream. Now this is leveraged in your streaming API, that is your structured streaming API. You have seen a flavor of this in the module 1 when we looked into the systematic refinement procedure, or the delta lake architecture as we popularly call it as, right? So there you had done spark.read stream, spark.write stream. So all that essentially happens to be this happens to be structured streaming API construct. This we will revisit in module 11. Module 11 focuses on the details of the structured streaming API, that how that API helps you design streaming data frames and subsequently carry out structured stream processing on top of them, right? So this is our Spark session class. We are interested in this class because at the end of the day, this class is what helps us author create data frames on the with different file types, and it has all other methods also, create data frame, SQL and table, which are also very handy sometimes. Okay, so till here we are clear that we're gonna get a data frame using this class. Then what do we do with it? Do we watch it? Do we play Spider-Man with it? What do we do with the data frame? So essentially we carry out operations. So what operations will you carry out? Let me close these links now. So what operations will we carry out tells us the data frame class, right? So if I go to the next core class, the data frame class, let me click on this data frame class. Here is the soul of the entire SQL data frame API module. You look here, this is the most crucial class in the entire SQL data frame API. Data frame, panel data, distributed collection, because you are carrying out distributed processing. Such a high volume of data cannot be done vertical. You cannot process the data vertically. You have to do horizontal. So distributed collection of data grouped into named columns, just like you have the columns and rows. In a similar way, it is also a distributed statically typed object, right? Which means it has static typing in it, which means it is the types are known at compile time itself, right? Hence it is structured, it has a schema. Okay, so it will have column names and their data types known to us at the compile time itself. It is equivalent to a relational table. You can treat it as equivalent to a relational table in Spark SQL. It is as if it's a table. We know that Spark session class helps us author that object, the data frame object, spark.read.load, spark.read.parquet, spark.read.csv. Once it is created, then we manipulate it with a domain specific language. Data frame class and the column class essentially help you to carry out operations on it and column expressions on the columns sitting inside that data frame. Sometimes we just don't want to process a column, we want to process an expression on a column. 10 times the salary, 10% of salary as commission. So sometimes we manipulate expressions on columns. So the column expression class is super important. The column class which helps you operate on column expressions. So if we look at this crucial class data frame, we see beautiful methods sitting inside this. Most crucial aggregation at the end of descriptive analytics. Why are we in descriptive analytics? Because we want to do groupings and aggregations. So this aggregation method helps you carry out aggregations. Aggregate on an entire data frame without grouping. Direct aggregation, where you first filter the data and then you carry out aggregation. We're going to do this, we're going to use it, and you will see how we use it. So essentially groupings and aggregations, you're going to do that. Alias returns a new data frame with an alias set, which means renaming the columns and creating a new data frame out of it. Approx quantile. Now there are so many of them that not all we're going to be leveraging, but there is another course that I will be sharing with you. It is a supplementary course along with this course. Microsoft wants me to share it with you, in which you will see advanced transformations on a data frame, which are carried out in machine learning projects, because covariances, correlations, encodings, vectorizations, right, imputations, these transformations which are on the higher end of the which means understanding, to understand them you need to look at some data science also. They happen in data science projects only. We just normally do in data engineering. What could you do? You could change data types of the columns, you could cleanse the columns, you could drop null values, you could impute them with mean median mode so that the central distribution does not change. You could scale, you could normalize, you could cache, you could carry out aggregations, author your aggregations. That's it, right? Typically you're not going to carry out some advanced operations. So when you look at these operations, some of these operations typically are used in data science projects. So there is one beautiful course, DP090, that I will be sharing with you, self-explanatory course. You would be able to try it in your subscription, right? And that would assist you to leverage some advanced methods of this class, data frame class, right? So there are so many of them. For instance, caching, which we will be looking at. You could cache the entire data frame inside the RAM throughout the execution, that is throughout the session while the session is active. It will not gonna flush it to the disk. Okay. Then you have correlations, right? So calculate the correlation between the two column. Other methods are also there. Counting, one of the most basic method, count the total number of rows that are there in this data frame. Covariance, then these will be important for us, right? For instance, create or replace a temporary view would be important for us, because if you say that I have expertise in NC-SQL, I would like to query this data frame using standard SQL, NC-SQL, select a star from and all that, rather than Spark SQL, which is this itself. So you could say I would create a temporary view on this data frame and then query it with a standard SQL. So this is important for you. Cross joins, cubes, right? Describe, very popular, right? Gives you basic statistics for numeric and string columns. You see in exploratory data analysis, the most crucial method being describe. Distinct tells you all the non-duplicate rows on the basis of a certain column. Drop the columns that you don't want. Equivalent of selection. Either you select the columns that you want or drop the column that you don't want. The result set would be same, right? So if I have 4 columns A, B, C, D, I say I want to select A, B. Essentially, you are dropping C, D. So either you select or you drop, right? So drop the columns. Drop duplicates, drop underscore duplicates. It's just a nickname of this, right? So you will see some methods have clones of them. Okay, drop duplicates. Drop duplicates is an alias of this, optionally only considering certain columns. So it will tell you, hey, you want to drop duplicates. How do you identify duplicacy? On a basis of an entire row, all the column values must be non-matching, unique, or on the basis of a certain column only. So here you can see drop not available. So drop missing values, rows such that the rows which have the missing values. Explain, fill the missing value. Imputation, right? So this is your imputation. Okay. Impute, filter, where clause, equivalent to a where clause. First row for each partition, frequent items, group by. Now these two are although aliases of each other, but you can see here you have the most crucial methods that you would be leveraging, group by method. Okay, so you will be grouping by a certain column. Group by employee ID, count the total number of visits of that employee to know how many days that employee came for an office in the entire year. Head, return the first n rows. Intersect, is empty, is local. Join, limit the result count to a number of specified. You'll be leveraging these. Order by, sorting, right? Persist, alias of caching only, both of them are same. Print the schema, tell me the column names and their data types and the structure of the data in the tree format. JSON will give you nested hierarchy. Parquet will give you flat hierarchy. CSV will give you essentially flat hierarchy. JSON is a hierarchical file, so it will give you a tree format. So you'll see that so many methods are there. Roll up, same semantics, select. Now this would be important for a selection. Selection and dropping are equivalent of each other. Either you select the columns or you drop the columns that you don't want. But select has one advantage, which you can clearly observe, is star columns. That is a column expression. So drop cannot help you do column expression. So if I say I want to select AB, that is equivalent to dropping CD. But if I say I want 10 times of A and 20 times of B, then drop cannot help you, select will help you, because it will help you author an expression on a column. 0.20 into column A, 0.10 into column B, expression. 10% of salary and 20% of commission. I want to select out of this data frame. So select will assist us in getting a column expression out. So that's the most powerful thing in the select, which differentiates it from drop. Otherwise, select and drop are just two black and white situations. Show, it's going to print the result set to the console. Nobody uses it because it prints it like you are living in the olden ages. Prints it to the console. People use display rather than show because display has some advantages, like you'll see it has advantage. It allows you to sort. It gives you the central tendencies and distribution statistics automatically. It helps you do charts, which the show does not. Sort, summary, okay, used by data engineers. Creating another data frame out of the existing data frame. JSON, right? So many are there. Where, so these all are various operations that we could carry out on a data frame, and you're going to be leveraging these. As you will see, you'll be using most of them is the most popular out of them. So once the data is processed, after you carry out these transformations on the data frame, on your raw data frame, what will you do with it? You're going to write it somewhere. So there is a method, write and write the stream. In the data frame class, not in the session class. Read method was in the session class, write method is in the data frame class, because writing of the data frame has to be done. So here we have write method, amazing. This method returns a data frame writer that helps you do writing to some SQL using JDBC, Java database connectivity, writing in the CSV format on a lake file, right? Parquet, write it as a Parquet, save as a table, sort by text. So you're going to be leveraging this wonderful data frame writer class to write it to a lake as well as to SQL structured sources for multidimensional modeling. So Spark session class help you create data frame. Data frame class help you process it and then subsequently write it. ETL can be carried out now using just two classes. But sometimes these methods might not be enough for you. For instance, there was nothing like calculating a cosine of a certain value. For instance, there are only 24 hours in a day. Rather than having values 1, 2, 3, 4 till 24 distinct values, a data engineer could encode it and bring it to a smaller scale, 0 to 1 or -1 to +1, by calculating a cosine on that, right? Or sine of it. So sine of the hour column. So if you have an hour column in a data frame, you could say, let me scale it down, normalize all the values between 0 to 1. So you could then calculate a sine of that column, right? like that. So that we don't see here. So then you have functions. No, you would be able to carry out functions. Okay. So here we have functions. So you can see that we also have super duper functions right under. In case operations in the data frame class are not sufficient for me, and I would like to use some advanced methods of various natures. One example, as I gave you, encodings when you do normalization, scalings when you carry out, such methods are helpful, right? Values which are looping, you could use trigonometric functions, hyperbolic trigonometric functions, and so on and so forth. And so on and so forth. So many functions, just an example we added here. Some normal functions, call, column, and all these. So we're not going to be discussing all of them, right? Some of these you will be leveraging in your learning, and obviously these you will leverage once you have need of using them. So they are sitting inside the API, SQL data frame API classes, SQL API, Spark SQL functions, square root, absolute, arc cosine, hyperbolic, sine, r sine hyperbolic, and so on and so forth. You see so many of cotangent, cosine, and so on and so forth. So you can see all these methods are there. Radians, date time functions. Now date time function would be of crucial interest to us. Yes. Why? We are doing reporting. The time dimension in a report is the most crucial dimension for everyone, right? Generally, your decision makers will essentially ask you to filter the reports on the basis of time. And if I have a data that uh, I need to have it in a proper time dimension, then the date time functions. These functions may be of crucial interest to us. Add months, current date, and so on and so forth. For instance, you would be even leveraging few of these from Unix timestamping. So you would be doing this. Okay. You would be also playing with some data types. We know that big data has high veracity in it, which means data quality issues will also be there. Sometimes type issues would also be there. I want to carry out some operations on the data which the current type does not support, right? For instance, I could have a column in which the date is mentioned as a string. Then I cannot carry out date time operations on it. So someone could create a data frame in which there is a column called as timestamp. Although the name of the column is timestamp, but that person essentially has kept it as a string. So it would be like this, right? 1970 0101. It is a string, although it is a string that looks like a date, but it's a string at the end of the day. So its data type is a string. Now, if I want to say that add 12 months to this, whatever this value is, add 12 months into it, add underscore months 12, that is not possible. Type is different. So sometimes, as we know that in the data, we need to do some implicit conversions, castings, explicit coercions, and so on and so forth. One of the example would be to basically take a string, which is essentially having a format of a date or a date time, convert it into its Unix timestamp, which is the number of seconds elapsed after the birth of Unix, which happens to be the midnight of 1970 January 1, which is the same thing. That would be 00000, long value. So that would convert it into a long integer, long int. So if you ask a Unix timestamp of it, so if we ask a Unix timestamp of this string, and then you obviously attach the time to it, and then if we ask the Unix timestamp of this, it's going to give you 000, because that is where it starts, right? The birth of Unix, 1st of January 1970, the midnight hour. And then we have to tell it in which format this string is written, so that it can understand where are the years and where are the months, right? And where is the date, and then how is the time authored, right? So you're going to tell it exactly and ask it a Unix timestamp of this. So it's going to give you a long number like this. And there, you know, right, that there are various websites that help you calculate the Unix timestamp essentially. Here it is. So I could ask a Unix timestamp of any day, any date over here. For instance, let us say some random date I'm picking, 2021, month maybe 3rd, day might be, let us say 19, hour something something, convert. So that gives you the long integer, which happens to be the Unix timestamp of that date time. Now, if you cast it to timestamp function, cast it to timestamp data type. So here we have data types right under data types. So you could play around with primitive data types. So here are functions and then here are data types. So you could play around with implicit data types and primitive data types and explicitly designed user defined types, right? So array type, boolean type, binary, byte, data type, these are some primitive types. But then we have some which we can design ourselves, which means classes. Just like class is a user defined type in object oriented programming, taken from the great programming language Simula. So we have this concept here, struct and struct field, just like in C. In C we have structs and unions, right? So we can author that here, struct type, struct fields, that help us author a user defined data type. So if I cast this value, obviously I cast this number into timestamp, that gonna spit out something in timestamp format. So that will convert this number into equivalent date time, but this time the data type will not be string, but the data type would be timestamp. And once it changes to timestamp, I am now going to say add months, write year of, like that. So I can then carry out the desired function, desired operations on that type. So type conversions, castings are also needed because we will see that data might not be in the form and a shape and the type that we need it to be. So these data types. Similarly, when you are designing schema on read or schema on query time, whatever you say, schema on read, schema on query time, then also you need to design your schema object to parse the data and evolve your schema. So these types again become more crucial for us. So functions, the types, grouping, amazing. This grouping is the king of the jungle at the end of the day. At the end of the day, you're going to have to group the data, group by, and calculate counts, max, mean, min, and all these things.
So guys, if you liked our video, then do give us a thumbs up. But if you really want to learn more about the particular topic we discussed, then we have something really special for you. We have our free class on Microsoft Azure Data Engineer certification, that is DP203, along with some question and answers, where we'll be discussing about why is everyone working on data, importance of some Azure services you should learn, and many more things. So for that, all you have to do is just log on to k21academy.com/Azure DE02, and after that you'll be seeing a screen like this. Just click on book your free seat now. Select your event date whenever you're available. Reserve your spot by adding your name, your email address, and your phone number, and you'll be getting all the updates via mail. You'll be seeing this kind of window on extreme right, so you can save this link, add to your calendars, and I'll see you in the free class. Till then, keep hustling and take care.